Okay, is everything being displayed for everybody correctly? Should see something called a dummy load up there. Okay, cool. So tonight, I thought I would talk about something pretty basic. That's a dummy load for. So we're going to talk about, learn a little bit about what a dummy load does, size and types of dummy loads, how to use a dummy load, and how to select a good dummy load out there. So for ham radio operators, there's four pieces of test equipment that is just always seems like a must-have. And, first thing that I'm sure every ham radio operator has is a good old digital multimeter to be able to read resistance and current and voltage out there. Another one is good old antenna analyzer. Helps tell you that um, your coax is good, your antenna is will resonate at a particular frequency, so that's an absolute given tool. Another one is having some kind of a meter that you can measure power in SWR. One of the things is that when you're using we kind of use the antenna analyzer to tell us that, hey, we got a good match or we don't. But I'll be darned, there's still limits to what that antenna analyzer will do. When we start adding a load to a piece of coax or an antenna, it can behave very differently. So an antenna analyzer is just going to be giving you milliwatts out there and looking at how that power is reflected back. So it's also nice to have a decent power meter. It's also nice to have something, a power meter that will also show you the SWR. So this is kind of a good indicator that you can use to show you what's going on when you have things loaded up. The other thing, fourth guy that I kind of believe is one of the essential piece of test equipment is a good old dummy load. Dummy load's a pretty darn simple device. It's basically, it acts as a load out there. It acts as like an antenna. It acts like a 50 ohm load that we know that we like to use in our all of our ham radio and antenna systems. So we're going to be talking about this particular piece of test equipment. So what is a dummy load? So it's a device used to simulate an electrical load for a transmitter. I'm not so sure about the term simulate. I mean, it provides an electrical load that's appropriate, a 50 ohm load for a transmitter, and it helps you to eliminate problems. So it's a non-radiating antenna with a known impedance. That impedance is 50 ohms. And when I say non-radiating, it's supposed to be not like an antenna. Now, in fact is that it will radiate a little bit. So it's not a totally isolated thing, but it's not intended to radiate a whole lot. The key point is not inductive, is not capacitive, meaning there won't be any reactive component to what you are reading. So it's purely resistive. If your dummy load is made correctly, it should be purely resistive, and it won't have any SWR. It's supposed to be 50 ohms out there. Pretty simple. Now, when you're selecting a dummy load, you have dummy loads like for HF, you have others for VHF, UHF, you have some that are built for even higher frequencies and such as, you way up in the microwave band. But you want to end up picking one that's in the proper perspective as far as, are you going to use it for HF or are you going to use it for VHF? Sometimes you can get expensive ones that can handle both of those spectrums. You also, when you're selecting them, you want to need to think about what kind of power you're going to put into it. Are you going to be testing and checking things on an HT? So all you need is 5 watts. Is it going to be a regular um, base station, so you need a 100 watts out there, or you're going to connect up a amplifier, something that runs a kilowatt or 2.5 kilowatts, whatever. But it needs to be sized correctly. So one of the things you'll find is that each your um, dummy load is going to be built in such a way where it will specify a duty cycle. Like a lot of them say a 50% duty cycle or a 20% or 25% duty cycle. So here, let's take a couple examples for a 50% duty cycle. So if you have a dummy load that's rated for 300 watts, it can handle basically 300 watts for about 30 seconds with about a 2-minute cool down period. If you try running it over that 2-minute or 30, excuse me, that 30-second time, it's likely to get too hot and it may end up letting the smoke out of the box there. So that 300 watt dummy load, if you want to run it continuously, it's basically about 25 watts continuously. You buy one of those big honking dummy loads for 2,500 watts, it can handle 2,500 watts for about 60 seconds max. And then you need to take and shut it down and let it cool down. So typically, either in the documentation or on something on the um, something that is either attached to the dummy load, it'll give you this little curve. So this curve basically tells you how long you can run it at what power for what number of minutes. So this guy is a 300 watt dummy load, so it points out that you can run it for about 30 seconds out there if you look at the curve. If you need to run it at full on, excuse me, let me try it again. So if you want to run it at 100 watts, you can run it for about a minute and a half, and that's about it before you let it cool down. But anyway, looking at one of these curves here is really important because every dummy load is always built differently internally, but this will give you some guidance on how long you take and do a key down. But usually by that point in time, when you start getting out to a couple minutes of key down power, the finals in your transceiver is going to start getting a little on the warm side. So dummy loads are made from a lot of different kinds of stuff. You can have them carbon resistors. You do not want anything that's a wire wound, a type of resistor. They can be made from carbon ceramics. They can be made from a carbon rod immersed, excuse me, in oil. And the old timers will remember this. This is called a cantina, and I have a picture coming up on what that looks like. So all dummy loads are limited by its ability to dissipate heat. So the number one thing that's going to limit how long it can work or you can run power into it is always by its size, and that's the guy that limits it. So a good dummy load should show an SWR of 1.11 or 1.1 over the entire frequency range with no reactive components in it. If you have any reactive components in it, you might check your coax that's connecting it to your transceiver. So here's a couple pictures. The one up in the upper left-hand corner, that's a really deluxe one. Very nice. I think it's good for about 2,000 watts there. Has a built-in power meter built into it so you can see what the thing is doing. The one down the lower right is a good old, trying to remember, I think that's a carbon resistors in there. I don't remember exactly what's inside that one, but it's a good old standard one that is very nice. If you have one for running a 100-watt rig and testing that, you can run that out to what about looks like about almost 3 minutes there. Actually, it looks like for this guy here, you can run 100 watts continuously on it for that one. So here's a little micro um, dummy load. So this is actually, there's kits out there. You can build these things up. So here he's put together a bunch of little carbon fiber resistors, a little circuit board, and built the thing up by himself. This is a good old cantina. So used to buy these things. They weren't too awfully expensive, but the mineral oil that you poured into it made things pretty expensive. So you, it's just like a paint can. It's a 1 gallon paint can. You have to buy a gallon worth of mineral oil, fill it up, put the lid back on it. The trick is that when you run a load into it, this guy will get hot, and you'll end up finding that sometimes oil will leak out through the lid or leak out through the PL259 on it. And these things you always put in a bucket, a 2 gallon bucket. So if it leaked, it had some place to leak into rather than all over your ham shack floor. And you can see all the information on the side of it, talking about SWR and talking about how many watts you can dissipate and for how long it'll take you. So how do I use it? What the heck good is it? Well, it's a cool piece of test equipment. So a lot of times when I get a brand new transmitter, like let's say I buy something off of eBay, I kind of want to test it out to see if it's any good. Before I connect it up to an antenna, I'll connect it up to a dummy load, and then I'll transmit into that dummy load. And if it looks like it gives me the right amount of power out and doesn't have any artifacts as far as going crazy in SWR, then chances are I have a pretty good transmitter in that transceiver. So what happens if I have my antenna analyzer out and I look at my coax, look at my antenna, and then the SWR looks like it's okay, but when I throw a little power to it, my SWR starts going crazy. So I think everybody kind of understands that when you hit it with transmit power, you're not dealing with milliwatts, you're dealing with a lot of watts, and that also can drive quite a bit of voltage out there and quite a bit of current. So if you have any weak component inside that coax, it can cause arcing or cause a loss of, uh, of load for that transmitted power. So it's a good way of stress testing your coax. So a dummy load is not intended to test your antenna, but if you have a problem, you can use it to try and figure out, well, is it the problem with an antenna or is it the problem with my coax? If you test the far end of your coax with a dummy load and it all looks like a good connection, then you know your antenna, your coax is good. So the problem is most likely somewhere in that antenna. So let's see, I've already talked about the good old antenna analyzer only really puts out just milliwatts. So it's not a proper load test. So, and we've already talked about creating lots of power when we crank up our transmitter and transmit through it. So let's see. So anyway, good old antenna analyzer. Any of these things that I've talked about here, it's not going to see it. You're not likely to see it. So you need to end up testing it with a load. So sorry about this, but should have gone back through some of these slides here. So how do you check your coax? Just disconnect your antenna, connect up a dummy load at the far end, throw some RF into it, key up. You want to do it either with FM, CW, or RIDI. You don't want to use single sideband. You need a power meter in there. It's usually the stuff in your radio will probably show what's going on. If it all gives you constant power out there at that particular power level, then it's probably pretty good. If you have your SWR bouncing around, you seem to have you'll probably have a problem with your coax there. So let's see, I've already hit this one here as far as if, buying something you don't know. And I just kind of do that even when I get something brand new. I want to test it out and see if it really meets, especially like handhelds, they'll claim that it puts out 5 watts, but when you really load it up, it only puts out about 3 watts. So it's kind of nice to be able to connect up your HT to a nice little dummy load and power meter and see what actually power is actually being transmitted through the thing. Yeah, and the other thing to remember, if you are seeing a bunch of SWR and you're not seeing much power, most of your new rigs out there, they will automatically back off on the power there. So you're not going to see a whole lot of power. That's why putting in the a dummy load is cool to look at. So a couple other uses, you can use it to also check out coax switches. I did buy a coax switch once upon a time, and it kept giving me funny results. And I connected up a dummy load to the switch and found out that it had the contacts inside were arced over. So that switch was not any good. It's good for current chokes, checking them out, all the connections in that to make sure all that works out good. Um, let's see. Also, another thing that a dummy load's good for, and that's for tuning up amps. So it's really kind of good where you're not dealing with a tuner and you're not dealing with coax and a bunch of things. If you want to check out your amp, you can connect it up to a dummy load, and especially like your tube amps where you have to go through there and um, um, got a couple knobs on the front there that you have to adjust. It'll help you tune the thing, and then you can write down the settings on that. And then when you get on the air, you know exactly pretty much how to end up setting the thing to get the proper power out of your tube amp. Let's see, a couple other things to consider. We talked about dummy loads. The old days, they used to use 100-watt light bulbs. Well, it's not good as a dummy load, but it will help you maybe tune. If you're working within 100 watts or so, it'll help you end up tuning an amplifier or tuning a radio, but it's probably not going to work correctly as a dummy load. So one thing to remember is that when you buy an SWR meter or a power meter, usually those things only have an accuracy of about 10%. And that's the garden variety. If you really spend some extra money and get a lab quality power meter, then you can get below that 10%. But most of the garden variety stuff is only good for about 10%. Um, and then the other thing to remember is that dummy load is not supposed to radiate power, but it will radiate some. So I've heard over and over again where guys were transmitting into a dummy load doing some tune-ups, and the neighbor ham radio operator was able to hear them, and they were able to carry on a conversation uh, across using a dummy load. Another thing that if a dummy load works better than an antenna, likely you're going to have some kind of a problem with either that coax or an antenna. So it's if all of a sudden you're getting a 5.9 report off of that dummy load, you know that you have a problem with either your coax or your antenna, so you might want to look at that. So let's wrap it up here. So
Since the release of the Twist outbreak,
so when you select a dummy load based on, you want to select it on based on power dissipation and frequency requirements. Pay attention to the power rating curve. So you can usually find that in the documentation that you get with it. So you might want to read through that so you understand how long you can run power into it. So heat is your enemy here. Do not overheat your transmitter or your dummy load. Um, all all that wattage that you're sending out, it all gets dissipated in heat one way or the other. So it's either in the finals or it's going to go to the dummy load. Used to track down, really it's intended to track down coax problems, but it will also help you eliminate if it's not that it's not a coax problem, and so it means your problem's either in your antenna or balun. To help identify transmitter amp problems, it's kind of nice. Sometimes you can load up an amplifier or sometimes even a tuner, and you can put some power to it. Like if all of a sudden in your tuner you're getting some arc over, that might help you to eliminate or solve a problem in a mechanical tuner that you have. After your DVM, or your multimeter out there, antenna analyze, SWR meter, I think the dummy load is really the most used piece of test equipment that I use in around here. So that's all I had to talk about this evening was thinking about dummy loads. So back to any questions out of any of this stuff.
So Mike, I have a question. Maybe you covered it, and I walked away for 2 minutes. Is this do dummy loads, are they frequency sensitive, or is one dummy load work for all bands?
Dummy loads are usually frequency sensitive to the point where you usually get one for your HF frequencies, and then you get another one for your VHF, UHF frequencies. So you do need to pay attention. And also, um, sometimes, like that old Cantina one, when you got up into the higher frequencies, some amount of SWR would creep into that thing.
Hmm.
So it was for the day, it was pretty good, but the newer ones you get these days, they're a whole lot better and you have less creep with problems in it.
Thanks.
Any other questions out there from anybody? Okay, you guys.
All right. Thanks,
Thanks,
Mike.
Mike.
All right. Let's see here. I think that might. I lost my agenda.
Okay, well, while you're searching for that, I got a couple of more comments.
Okay, go ahead.
I think I've already mentioned the fact that right now we're kind of on the declining side of our solar cycle, and so it's declining, but still we're getting some pretty good openings. About 2 weeks ago, people have been complaining about not really having any openings on 10 meters. But we had about 2.5 days where 10 meters was wide open, clear into the evenings.
Wow.
And but if you look at the numbers, our solar flux index was at 229. It was huge.
Hmm.
And so the sun was being very nice to us and not flicking a bunch of CMEs at us to mess up our ionosphere. And it was very nice. So things are still happening. 10 meters isn't too bad today, this afternoon, late this afternoon. But um, if you're going to be working on that DXEC, you got to be hitting it pretty hard right now. Also, we're coming into the season where more expeditions are going to start happening, and we're coming into the winter months, so the lower frequencies are going to be opening up nicer for us.
I know that 6 meters was open some over the weekend. And then I was out near Riley, Oregon, out in the central part there. And boy, 20 meters was hopping over the weekend.
Yeah, yeah. 20 meters has been uh, I mean, it's alive in the morning and it gets way into the evening. It's been a real workhorse out there to capture stuff.
Yeah, I just want to say, yeah, we are on the decline now, but it's going to take years before it really gets bad because it's an 11-year cycle. So we just passed the solar sorry, the sunspot maximum, I guess the height of the solar cycle, and that was just last year, I believe, or even earlier this year. So it's going to take a while. So it's not like it'll go from all or nothing. It's it's a slow decline. But once we do get to solar minimum, say 4 or 5 years from now, it's going to be tougher to get your DX stuff, but you still can have a lot of enjoyment over the next, say, 4 years, at least 3 years before it starts really noticeably looking, sunspot numbers get down into the hundred, like below 200 and or consistently below 200, 150, and then you get down. And sunspot, I'm sorry, the solar flux index, not the sunspot numbers. And then the sunspot numbers go down at solar minimum down to zero pretty much, or very, very close to that. And then the solar flux index is down around 60, 70, something in that range there, but consistently below 100. And then that's when we have issues with propagation. But as long as the sunspot numbers are reasonable and the solar flux index is reasonable, we should be looking pretty good. I mean, it won't be every day, but it will be, more or less pretty fairly good propagation on an average. So do you agree,
Yeah.
Mark, with that?
Yeah, we were really hoping for a double dip out of this one here to give us a little longer at the top end, but we're past that point at this time, so we're not going to, there's nothing absolute about solar cycles, but the probability is that we're not going to get a double dip, so we get kind of two high points there, like a double hump camel. So we're not going to get that. We're probably good for decent DX for the next 2.5 years.
Excellent. Thanks, Mike. And I can find that those are very valuable tools, especially when you're trying to buy something at a Hamfest. And maybe something off my table. I had to throw it in there. At the upcoming Swaptoberfest, bring your dummy load, and you can see that it transmits on 100 watts full, or at least in my case anyway. So I also put something out. I forgot to mention that I'll be in Pennsylvania for the Pennsylvania CUSO party with my
Yeah.
my old team, and going to be doing that this year. I'll actually be traveling for business, and instead of coming home on a Friday, I'm going to come home on Monday. So get to work and play. So should be a lot of fun.
When is that, Paul?
What's that?
When is the Pennsylvania QSO party?
It's in October 11th and 12th,
Oh, okay.
and much like it's only one state instead of like 7 QP. So it's 67 counties. And of course, any other ARRL section counts as a multiplier for in-state Pennsylvania state operators.
We'll try to work you guys.
Hmm?
We'll try to work you guys. I mean, I
Yeah.
will because
Yeah, I'll actually be sitting on 20 meters, so
okay.
with a tri-band beam. So hopefully, myself or somebody else on 15 will try to pick up some folks.
Fantastic.
Anyway, Mike, thanks for the great topic. Thanks for everybody for listening in and asking some great questions. And hope to see you at Picnic and Poda, and if not, the Swaptoberfest.